All right, so let's get started. Hello and welcome everybody to our talk about AEM Commerce and how you can extend it using Adobe I/O. My name is Markus Haack. I'm a software engineer at Adobe, working in the AEM Commerce team, and with me is Carlos.
Hey, so my name is Carlos, and I'm a software engineer working at diconium. And I work a lot in AEM and in commerce solutions.
All right, so let's get started. So we will talk today about AEM Commerce, the Commerce Integration Framework, and actually how we use GraphQL in the area. And you will see GraphQL is a very important piece of the puzzle here for integrating AEM together with the commerce solution. So what actually is AEM Commerce and how everything fits together? I have a little bit marketing-ish slide, but I promise that's the only one. So we have AEM here on the left side, and we have the commerce engines out there on the market, commercial solutions like SAP Hybris, Salesforce, and obviously Adobe Commerce, but also homegrown in-house custom commerce services our customers have. And in the middle, we have the commerce integration framework, which is basically the piece of the puzzle, the glue, which brings both commerce and AEM together and allows you to create commerce experience, build your online storefront. The key pieces of AEM Commerce are basically three parts. There are the commerce core components. That's the components which are used to build the online storefront experience. Second block is the CIF offering tools. That contains all the tools you can provide to your offer people and your offer community to create the experience. So it contains a product console where they can navigate the catalog within AEM without switching context and logging into the commerce system again. They can all do this from AEM. It contains pickers, etc. And the third building block is the integration layer, which allows you to connect AEM to Adobe Commerce or to other commerce solutions. The architecture, a little bit high-level picture of it, looks like a typical AEM deployment at first, because AEM Commerce is actually built on top of AEM sites. So we have a classic deployment, either on-prem or AEM as a cloud service with publish, offer, dispatcher, nothing special. The CIF core components are actually a set of server-side and client-side components. And the way how the communication to the e-commerce system works is basically you get the request like normal on this side. The request hits the AEM dispatcher and the CDN, and let's say it's not cached, it will hit the publisher. And the publisher, if it's rendering the page, and the page contains commerce component, like you display a product list or a product carousel, it will do a GraphQL call. The same applies if you have client-side components. The only difference here is they do the GraphQL call directly to the GraphQL endpoint, and you bypass actually AEM publish instances at all, because there is no extra need to have them here as just as a proxy. On the GraphQL side, for integrating with third-party solution, we use Adobe I/O. If you use Adobe Commerce, then it's slightly different, and you will connect directly to them. We provide a GraphQL endpoint, which is basically a collection of resolvers which implementing the Adobe Commerce schema. They will handle the GraphQL request, and they allow you to integrate with the commerce system. The integration is basically a set of serverless functions. You see that in detail in a second. They handle the communication to the commerce system and do the data mapping, etc. And there's also the possibility to deploy extensions on the I/O layer. That's, for example, the use case if you use Adobe Commerce, where you don't need the I/O layer by default, but if you want to extend the schema, or if you replace functionality of the existing schema, then you can do this on Adobe I/O. And speaking about Adobe I/O, that's the area which we now going to look into detail, because as I said in this talk, we want to focus about integrating third-party or homegrown commerce solution, and that's what Adobe I/O is used for. The GraphQL part. So GraphQL, as I already said, is a very essential part for the CIF integration. All the communication, doesn't matter if it's by the core components or by the CIF authoring tools, pickers, consoles, happens always via GraphQL. We are standardized around the Adobe Commerce GraphQL schema. We try to keep it up to date with always the latest schema and greatest extensions. Magento has, or Adobe Commerce and Magento, they have also regular releases, adding more and more functions to the schema, providing more and more queries. For Adobe Commerce, this communication between AEM and Adobe Commerce is the direct communication. As I said, by default, there is no I/O in place, but you can use the I/O layer to implement extensions. For third-party commerce solutions, we use the Adobe I/O layer basically to map between the proprietary backend APIs and the data format and map them to our schema. To get you started and to help you with integrations, we provide a GraphQL reference, and that's the one I will use now in a second to also explain how the actual architecture looks like in detail. For the GraphQL reference, the idea is this is gives you a starter and a project blueprint. It's available in the public GitHub. It's a standardized Adobe Firefly project. Basically, it means we implement a set of I/O serverless functions. They are implemented in JavaScript. You can take it, deploy to your I/O account, and immediately get started and play with it. And then you take this further and integrate this with your commerce solution. For example, like SAP Hybris, that's what Carlos will show you in a few minutes. The idea is, and that's very important also for your project, it's not implementing the entire 100% schema. So there's no full coverage of the schema. It's really implementing the main core parts like the products, objects, and category objects, and a little bit of the shopping cart, with the idea to showcase more how you do it and how you can build it. And that's the same pattern you can apply to your project. So depending on your needs and requirements of the project, you typically don't go and implement 100% schema coverage because that's very unlikely you need it. And depending what you want to achieve, it's also okay to just implement subsets of the schema to implement a product search or a category navigation. So talking about the architecture, how is the architecture look like? This is the very simple and basic diagram of the architecture looks like, and actually that's almost it. The key element of the GraphQL implementation we provide you for the I/O is a dispatcher action, not to confuse with an AEM dispatcher. It's a different thing. It's a dispatcher serverless action, which is deployed on Adobe I/O Runtime. And that action exposes an HTTP endpoint, which is basically getting all the incoming GraphQL requests. If there is a GraphQL request, so what do you do with it? You need so-called resolvers to basically deconstruct the request, understand this, the incoming query, and have a resolver for actually handling the functionality, doing some logic, and returning back a result. We have three options to implement such a resolver. The first two are also shown in the code on the reference implementation. The third one is not shown, but I have it here for reference to give you the full picture. The so-called, what we call local resolvers or built-in resolvers, it's just JavaScript code which is running inside the dispatcher action. The advantage here is it's running in the same Node.js process. It's just in different JavaScript class, which is doing the heavy lifting. The second option you have is a remote resolver, which is basically the dispatcher will delegate the actually GraphQL work. So resolving the parts of the schema, mapping it to backend call, mapping the data back to our schema and returning the result. And you offload this to a separate serverless function. The advantage here is that you can use this to implement different kind of extensibility pattern. You have separate caching layer, etc. And there's a pros and cons when you need the local resolver versus the remote resolver. The third option, as I said, not shown in the reference, is if your GraphQL or if your commerce service actually provides already a GraphQL endpoint, then you need to do less mapping. You only need to mapping from schema E to schema B, but you don't need to do mapping from a GraphQL call and transform it in REST or database query first. And this is possible as well, and you can register these external resolvers the same way like you do a remote resolver. When we talk about the GraphQL part, there are actually two main areas we need to cover and what the implementation is doing for you. First is the introspection. Typically, for almost every GraphQL implementation, you need to implement an introspection. The introspection is when the GraphQL client asks the server for the schema, basically asking the server, hey, what is actually the functionality you're providing for me? What queries do you support? What mutation calls do you support? And how is the data format looking like? The way how this works is there's the incoming GraphQL request. The dispatcher gets the request, and it will first ask the local resolvers, which are registered, to providing their part of the schema. So each resolver implements a subpart of the schema. So in this example, we have a resolver which provides a query which allows it to query for product categories, and a second one which allows it to query for products. The second functional step is the dispatcher action will check the configuration for all registered remote resolvers and invokes the IO function to get the inter-schema query forwarded to the remote resolver. The remote resolver basically does the same. It returns the subparts of the schema which are supported by this remote resolver. It goes back to the dispatcher, and the dispatcher aggregates the entire full GraphQL schema which is supported by the server, and this is then sent back to the client. It's also cached internally, so for repeating introspection queries, the flow will be a little bit different because the schema typically doesn't change during runtime. It only changes if you do a new deployment. So this is something which is cached by dispatcher, and because there's no need to aggregate it a second time. Once the client has the schema, it can ambitiously then query for real data. So we're coming to the query execution. And the query execution flow works very similar. Instead, the only difference is here, this is where the heavy lifting happens. So there is a GraphQL request incoming, same like the first time. It hits the dispatcher action. The dispatcher action will check if it needs to be delegated to a local resolver or to a remote resolver. In our example case, for categories and products, it will be the local resolver. In case it's a card query, it will be a remote resolver. The local resolvers, they will do the work immediately. So they will do whatever they are built for, like doing a REST call to the e-commerce system, looking up the data from a database, whatever is implemented there. The remote resolver will basically do the same. It's just, as I said, offloaded to a different IO action and running in a separate runtime process. Once both of the resolver independently of remote or local get the data back, they map the data they get from the backend system and transform it into the GraphQL objects. The parts of the GraphQL schema they actually support. So the card resolver action will return a card object with the card items. The product resolver, for example, will return a map product with all the product elements like product details, SKU, images, etc. Then the dispatcher will assemble the final result and send back the JSON to the client. With that, we basically learned the two most important parts which are implemented by the GraphQL server we are providing. So it's the introspection part and it's the query execution part. So how does it look like if you want to get started with this and implement this for your e-commerce solution? It's basically 4 simple steps which are helping you to getting started. The first thing you need an Adobe IO account. and the configured IO project. If you don't have it, then you can go to the adobe.io and register. The second thing you need is the command line tool, which allows you to communicate with Adobe I/O directly from your local terminal. Then you clone the project, and then you basically deploy it. You can run it locally with I/O app run, or you can deploy it to the server with Adobe AIO app deploy. And once you do this and you deploy the reference, you basically get the deployment of the set of GraphQL functions. And we also include an iGraphical user interface, which allows you to do some simple GraphQL queries directly from the deployment, so you don't need to configure extra your AEM and connect to it, or you don't need extra GraphQL client. You can just go to your browser, and that's what I'll show you in a second. How it looks like. If you deploy it, it will give you the endpoint URL of the web application which is deployed, which is in our case is the GraphQL I client, and this allows you already to execute the first query. So we see here on the right side, this is the supported schema. We support queries and mutations, and if you look at the supported queries, it's not mapping the entire schema of Adobe Commerce. As we said, it's totally okay to just implement the sub-portions of the schema you really want to support. And what you will see here actually in this example, that's what we do in the reference application. We're providing 4 parts of the schema, like the category listing, getting metadata, products, and shopping cart. But we also have a custom extension, which is not part of the core schema, to demonstrate how you can do custom extensions of the schema. So in our case, we implement a shopping list. That's actually really special to this implementation, and it's not part of the core schema. And if we do the execution of a few queries, just to demonstrate it, so I here have a category list query prepared, which allows me to query product categories of my commerce catalog. And if I execute this, it's calling the IO function. And I get the result list of categories. And to show you a little bit more complex functionality, I have a product query. This is actually more interesting because it actually hits a sample database in this case, which we are querying for 2 products. And I'm getting a set of attributes for my products. And if I execute the query, it's not returning dummy data anymore because it's getting real data from a database. So this is actually coming. The IO function is connecting to a database, reading it from the database, and returning it in GraphQL. I also can combine these queries and do multiple queries at once. Like here, this is the beauty of GraphQL, and the client has full control over it, so I can query for the products and for the categories at the same time, and the implementation will give me back both. If you look here, we get the category list with all the category children, and we get the products back from our client. This is what you all get with the GraphQL reference implementation. And basically, this is the starting point we give you for your project. With that, let me switch back to the presentation. Additionally, what I didn't show you here is also part of the project is all the boilerplate parts of a classic Firefly project. So the code structure is a standard Firefly project structure with actions and the web application part. It also includes tests for the code we provide and examples how you can do this for your own project. It includes configured GitHub workflows, which allow you to directly deploy to your Adobe I/O client, to your Adobe I/O account. So you can deploy it from the local CLI, or you can deploy it via GitHub as well. With that, I know it's interesting to play with a reference, but it's way more interesting to look into a real-life example. So what we have seen so far, we learned how the GraphQL is used by CIF and by AEM Commerce for the components, for the offering tools. I showed you the GraphQL reference, which you can go to GitHub and check it out. And of course, the reference, as I said, the reference is just one thing. Real life implementations is typically more interesting. So that's why I didn't show you that much code, because we have Carlos now, who is demonstrating you how his team built the integration for SAP Commerce using exactly the same pattern and exactly the same code as a foundation, which I just showed you. With that, over to you, Carlos.
Okay, thanks, Markus, for all the detailed explanation. I hope everyone liked it. So can you see my slides? Ready? Yes. Yeah. So let me click here on the hide. Yeah. Okay, cool. So, okay, Markus gave you a very generic, but at the same time deep description of what is the CIF and how can we start implementing it. So, at diconium, basically, we are Adobe partners, and we are also SAP partners, and we get a lot of requests. So we want to use SAP Commerce, which in the past was known as Iris, as our commerce engine, and then we want to have CMS on top of it. So mainly an AEM, usually. And yeah, we want to serve our shop, our complete front end. We want to have our components. We want to manage everything on AEM, but all the transactional things and all the product maintenance, we want to have them on Iris. So we basically got together with Markus and his team, and yeah, we started by forking the reference implementation that Markus mentioned. And yeah, we started to connect both worlds. So if we have a requirement and we have a way to connect them seamlessly in the, using Adobe I/O and this GraphQL connector, why not do it? And yeah, with that, probably we can get pretty fast results and quick, at least quick MVPs and things like that going live pretty fast for our clients. So yeah, that's what I will try to demo you here today. So how do we build this? So I will show you some code, and I will show you this working as well in an environment. So there's basically two magic puzzle pieces. So there's the AEM CIF components. Yeah, together with these, there's also the Commerce add-on package. So that's another package that we also need to have in our AEM instances. And there's the Commerce CIF GraphQL integration with Iris. So both these things are available on GitHub, so you can download it or clone it, and yeah, just have a look. You can deploy it into your Adobe I/O namespace, as Markus mentioned as well, for the reference implementation. You can also do the same for this real use case that connects the AEM with the Iris environment. So what you will find on GitHub, it's something that connects the completely out-of-the-box Iris system with the demo shop to the out-of-the-box CIF core components. So of course, it's extendable, and if you have something that's not on the out-of-the-box implementation, you can always extend the connector or the middleware that transforms both things. So then let's show you this. So I recorded couple of videos, so I will show it to you how it works. and I will also show you some code. So the first thing that I will show you, it's a basic product search on the Vinia shop. That we are going to search something on the AEM front end, and a query, a GraphQL query will come on the network tab, and eventually we will see some products coming out on the screen, and those products are sourced from the Ivory server. Let me just click in here as well, so then I can also show you the code. So I will start the video. I would ask you not to stop it, otherwise you will, otherwise we will crash it for everyone. So we have here the Vinia shop. So it's not off the box AEM. It's a 6.5 AEM with the CIF core components and the Commerce add-on installed on it. And so there's nothing custom. Everything is coming out of the box. And I'm doing a search, searching for Sony. So the Ivory's out of the box shop has some electronics store on it as an example. And we are seeing there on the network tab, so that on the first search there was a dispatcher call, and every time we change pages, there's a new call. So what's happening here, it's exactly what Markus explained you earlier. So we have our Ivory's connector deployed on the diconium namespace, and we have our dispatcher action. And we are doing, or better, the CIF core components are doing a GraphQL query, and then we transform it into a REST call to the Ivory's OCC endpoints, and we do all the necessary mappings so that the results are returned to the front end in the expected format from the components. So how does this happen? So let me open it in here. This was not the, I'm not sure why it opened in here, because I clicked on the link, but it's fine. I can find it. So we have the first thing, as Markus mentioned you earlier, we have the resolvers. If you noticed, so I also have GraphQL here open. And if you noticed on the video, we were doing a products query. So this means that on the resolver, somewhere there should be something to resolve products query. So that's what we have in here. This then will return, depending on what we have, it will return products by SKU or products itself. So we can navigate in here. Okay. And what we are going to see here is that we have some things which are called the loaders. So the loaders are where the connection it's really happening. So I have it open in here. So when we are loading something, basically, in this case, since Ivory exposes its data over a REST endpoint, so we will somehow need to call the Ivory's endpoint and basically, do a normal call. So we are looking for something based on an SKU. So we have a couple of variables, so you can set them up to point into your Ivory's instance, which basically are these global variables here. And then we are doing a /products call to the Ivory's and passing it a specific SKU. So just a normal HTTP request. So we get the data back. And eventually, so if I do it here, not sure if you noticed there before, basically what we are getting back out of this query, it's something with a type simple product with a couple of things in here. So then this product interface here, which basically it's what giving us the simple product. And we get in the props the information that was returned by the iris, and we just convert it into the expected results from the GraphQL. And then that's what allows the components to render themselves in the way they are built. So they were built to work with the Magento GraphQL schema, and what we do in the middle, it's basically transforming all the information that Iris returns us in the same way as the Magento returns its information to the front end. So like this, we have this seamless integration between two different worlds. So this was the first example, but yeah, we want to be able to deliver to our customers a full-blown shop. So I have a second demo here, so to show you that it's not just queries, we can also do mutations, and we can do a registration and a login, so we can have our user in there. So let me open this one as well and start the second video. So yeah, the registration and the login. So let me play it. Yeah, I need to change the quality always. So I will basically create an account. So again, I have the network tab open on the right side, and yeah, we will see what happens in here. So filling up again the out-of-the-box CIF core components registration form. Yeah, and when we press the submit button, we see some activity happening on the right side, and when we inspect it, we will see that this time it's a mutation that's creating an account instead of being a query fetching products as before. So we are sending the variables that we obtained from the form, and after that we can also do a login. So again, same logic as before. So the core components in place, no code changes in there. So we pick up again, it's a mutation, and we are sending the username and the password that we just registered, and we are logged in. Cool. So again, if we look into the code, it's same logic as before. So I opened here the loader, and basically in here, so if I scroll down, we can see here that we are doing registration on the iris. So basically this is the REST endpoints where iris is expecting a user to be registered. And yeah, we get all the information here from the body. So this is everything that the user placed. So this key dot first name, this key dot last name, it's the things that we placed on the front end, and then we obtain them in here. We create this body object, and then we just do a post into the iris endpoint. And we have a user saved on the iris database. Yeah, which again, completely seamless integration. So we have a registered user, and we are one step closer to have a full blown shop or a complete checkout process, which is what we want to achieve as fast as possible when we are starting an e-commerce project. So there's no shop without a cart, right? So the next part of the demo, it's really adding something to the cart. So let's see again what it's how is that done behind the scenes and what kind of queries are also involved in there. So we have PDP. So again, some queries here that are returning information about the product itself. So in this case, just one specific product. Yeah, we are bringing the price information. So we want to guarantee that's always up to date. And yeah, so we can see here on the response that yeah, it's basically bringing up the price in there. So basically on the core components, there are some things that are obtained directly from the AEM server. So those things can be cached, like the product name. It's not likely that it will change. But the price, for example, is something that we always want to guarantee that we have. So since we are logged in, we immediately have a cart ID, and at this point in time, there's nothing at our cart. So yeah, so maybe I can speed it up, just seeing some of the information that's already there on the cart. And yeah, now now when we edit, okay, so that's when we are doing again a mutation, and we are adding a single product to the cart. And basically, this is changing our cart in. So we added one item, and then we can see it in there that we have that product now on our cart. So this means that at this point in time on the Iris cart for my user, I already have a product in there. So yeah. Maybe I can speed it up a little bit because we are getting close to the end. So I think the next part of the video, I just add some more things into the cart. So I changed the quantity, and we have also the queries in there. But yeah, it's more of the same thing. So it's just to show that all the core components work completely fine, and that we can achieve it. So yeah, I didn't open it in here, but again, in terms of code, same logic. We will have a net product to cart loader, and it didn't open the correct one. Let me search for it. Product to cart. And again, the same kind of logic. So we are going to get the information from the front end, and yeah, we are going to call the iris, and yeah, in the end, we have a cart with some products on our e-commerce system. Okay, cool. So just to finalize our complete checkout demo, so we are also able to place an order. So that's the last video for the flow of buying something. So I have my products in the cart that we added before. We set up the necessary information that the core components are asking us to do. We say, okay, we are using the correct address. Okay. Okay. We say, okay, we want to pay with the credit cards. changing the card, so everything saved also on the Iris card. And yeah, maybe we set up the shipping information. So all of this information, it's required to be provided by the front-end components and also by the Iris system. And finally, we can just confirm the order. And yeah, we get our order ID, and yeah, we have it. It's posted to the Iris system, and it's ready to be processed and shipped. So we can get our cameras on the address that we placed. Yeah, since we have only 4 minutes left, I will. So in terms of the code, I think you already got the feeling how it works. So I want to show you one final thing, which for me particularly, it's one of the coolest things that I found on this integration, which is the authoring experience that we can obtain also using this. So there's a lot of components already out of the box, and of course we can always build our custom ones. But from the commerce ones, I will show you here on this on the video a product carousel, and you will see how easy it is to pick up some products that are served from our commerce system and show them on the screen as some content. So in this case, we set up some title, and then we have a product picker, and the products that are shown in there are coming out of the Iris system live. So it's again a GraphQL query happening on the back scenes. You can also, if you see on the top left corner, there's also a search bar. I think I didn't use it on the video, but it also works similarly to the inside search. So you can filter also the products in there. And yeah, you can select as many number of products. You can create new components. You can reuse the components that the CIF core components are offering you. And yeah, I think this authoring experience, it's really, really cool because it gives us a huge flexibility when we are creating these experiences for our customers. Just to wrap it up, what was our team experience during the implementation process? So you basically everything or the complete connector, it's built using Node.js. So you just need to know Node.js to develop it. Nothing special. It's completely standard. It's really easy also to do unit tests on top of it. Again, completely standard on Node.js. So we can easily achieve coverages of 100% without big issues. And it's really important because it helps you figuring out if you broke something. It's also very easy to have it on a proper CI/CD pipeline. No big deals on it. It's pretty well documented, so all you can develop. So there's some very good documentation provided by Adobe. And one of the coolest things here, it's the collaboration with our side and with Markus' team. It was really cool. So they were always able to help us. So we even got some in-person workshops before COVID, of course. And yeah, it was a really nice collaboration during the last 2 years or something that we started working together on this. And yeah, I think that's mostly it. So we are ready to get your questions. So just one last note at the end of the slides. There's a couple of references. So once you get the slides from adaptTo, you can also check the links on the last couple of slides. Hope you enjoyed it, and yeah, feel free to ask whatever you want. Questions?
There's one new question.
Okay.
Answer that now.
Yeah.
I think that maybe goes to. So the question to the audience is: did you experience any performance issues, especially making calls to commerce system? And if yes, how did you solve them?
Yeah, I can answer it from my side. So our experience with this is that, so we did a couple of tests, load tests, even mostly on the queries. And the response times that we saw were just, I don't know, 1, 2, 3 milliseconds slower than if we were calling the Ibris system directly. And if we would disable the complete cache, so the Adobe I/O Runtime also offers you a cache layer. When we enable it, and we can enable it for the queries, not for the mutations. Of course, when we are adding something to the cart, we don't want to have cache on it. We saw that it was even faster. So some of the requirements of our clients was that this caching time on the I/O layer was not that long. But we could still see some good results because if you are on your computer and you are making a request, and then I do the same request to the same product, then it's just one call to the Ibris system instead of 2. And although we just set it up to 10 minutes caching on the I/O layer, it really reduced the number of calls to the Ibris system. And yeah, that's basically our strategy. But still, even without cache, the difference in response time was not significant.
Cool. So thank you, everybody.
Thanks. Hope you enjoyed it. And
enjoyed the rest of the conference.
Okay.
Thank you.
Okay, thanks.
Thanks. Bye-bye.
Bye.